Hi, here is a nice improper integral associated with hyperbolic function. We have this integral as x goes from minus infinity to infinity, e to the minus 2i pi a z over cosine function z dz. Regarding number complex analysis, I'm going to choose this closed contour. This integral is taken for steps over this closed contour. We have contour C1, we have C2, we have C3, and we have C4. Okay? So we have C1, C2, and C3, and C4. So now, by applying the residue theorem, we have this integral f of z dz over closed contour equal to this integral f of z dz over C1 plus f of z dz over C2 plus f of z dz over C3 plus f of z dz over C4 equal to pi I, the sum of residue of this function, equal to 2 pi I, the sum of residue f zi. Zi is representing the number of poles. Okay, so now I'm going to calculate these four integrals individually. Okay, the first table I'm going to calculate the integral C1 and C3 and come back to C2 and C4. Okay, before I do that, I'm going to find out the poles of this function. Okay, we have cosine hyperbolic function z equal to 0. This is equivalent by cosine hyperbolic function definition. We have ez plus a minus z over 2 equal to 0. This is equivalent since e2 minus z over 2 is different than 0. Okay, this one must equal to 0. This is equivalent to e to z equal to minus 1. This is equivalent to z equal to pi I is multiplied by 2n plus 1 and as a natural number z. Okay, so that means z equal to pi over 2 pi 2n plus 1. Okay, since we have the theta between 0 to pi, so we have theta between 0 to pi, so that means we have z going to replace n with 0, so we will have z1 as a pole equal to pi over 2i. So the only pole that I have is pi over 2i. So now z1 equal to pi over 2i as a pole. Let's move on to calculate this integral over C1. Over C1 we have z equal to x because we are working along x axis. Okay, this implies this integral over contour C1 dz equal to f of x dx. Okay, the interval from minus L to L, which is over this contour C3. Now this one is going over x. Okay, is going over this range. So z has a real number and imaginary number. So z equal to x plus pi I. So this one implies this integral over C3 f of z dz equal to from L to minus L. From L to minus L e to minus 2i pi a. I'm going to replace z with x plus I pi over cosine hyperbolic function. I'm going to replace also z because we have the f of z here with x plus I pi. And if I'm derivating dz here, it's giving me dx. Okay, so this one, what I'm going to do now, I have two parts here. I'm going to multiply this one by this one. So this one is giving me I have e to minus 2i pi a is multiplied by x. I have also this one, e to minus 2i pi a is multiplied by I pi. So I'm going to multiply this one, I'm taking it outside. So I'm just going to multiply this one by this one. So it's giving me, so this one equal to L minus L. E, I'm going to multiply this one by this one, is giving me minus 2i pi ax is multiplied by 2 pi squared a. With this I is multiplied by I is giving us I square, which is minus 1. Minus 1 is multiplied by minus 1 is giving us plus 1. Is giving us plus 1. So this one over, as you if you take a look at here, this cosine hyperbolic function x plus I pi equal to minus cosine hyperbolic of x minus sign in the front. Okay, so this one is giving us minus cosine hyperbolic function x with minus sign here. So with this bound, I'm going to switch this bound from minus L to L. It become minus, with this minus become plus. Okay, we have dz dx. If you derivate this one, dz is giving us dx. So what I'm going to do now, I'm going to take this e to pi square a outside of this integral. So I will have this integral over contour over c3 equal to this one. I'm going to take this one outside. I'm going to add these two integrals, c1 and c3. Okay, so this one is giving us, if you take a look at here, this function is the same function here. I'm going to take this integral as a common factor. We will have 1 plus e to 2 pi square a is multiplied by this integral from minus L to L, e to the minus 2i pi a x over cosine hyperbolic x dx. Now I have calculated this both integrals. Next step, now I'm going to show this integral over c2 and over c4 are going to be zero. Now I'm going to show this integral over these paths c2 and c4 is going to be 0. Okay, with a theorem between 0 and pi. So I'm going to replace z. If you take a look at over the path c2, the z equal to L plus yi. Okay, with z equal to L plus yi. Okay, as a number complex. When this point get to the point L and keep going up over vertical axis, okay, which is represent number complex, when you get to this point and turn around over c3. Okay, so now I'm going to derivate this one. If you derivate this one, dz is giving us I dy. I'm going to replace this information into this integral. So from 0 to pi, we have e to minus 2i pi a z equal to L plus yi over cosine hyperbolic function, which is cosine hyperbolic function of this L plus yi I dy. Okay, what I'm going to do now, I'm going to separate this product. Now I'm going to simplify this one. I'm going to make this one as product. So if you take a look at here, this one from 0 to pi, e to minus 2i pi a is multiplied by L, is multiplied by another product, which is e to the I is multiplied by I is giving us I square, which is minus 1, with this minus 1 become plus 1. So we will have 2 pi a y over cosine hyperbolic function I'm going to replace this function cosine hyperbolic function with this L plus yi plus e to the minus L plus yi, okay, over 2. So what I'm going to do now, I'm going to bring this to up, put this to outside. So I'm going to apply the absolute value here, okay. If I'm applying the absolute value, this is multiplied by I dy. Now this equivalent f of z dz over c1 equal to this e to minus 2I pi ar is multiplied by this I over, what I'm going to do now, I'm going to simplify this one. I'm going to factor out this one, so I will have e yi is multiplied by e l plus e minus l is multiplied by minus 2yi, okay, is multiplied by this one, e to the 2 pi a y dy. If I'm putting absolute value here, this one it will be inferior or equal to this one, okay. Now I'm going to this one. If you take a look at here with absolute value, this term equal to 1 and this term equal to 1, because we have modulo of this one equal to 1, so we will have 2 from 0 to pi e to pi a y over el plus e minus l is multiplied by e to the minus 2yi with absolute value here. What I'm going to do now, I'm going to apply the triangle inequality here, as you have here. So we have x plus absolute value of x plus y is superior or equal to absolute value of x minus absolute value of y. Okay, I'm going to apply this theorem. Now I have absolute value of EL plus E minus L is multiplied by, I have this term. Absolute value of this term is superior or equal to, this term is superior or equal to, this term is superior or equal to this absolute value of EL minus, with this minus e to minus yi is multiplied by minus L. If I'm taking the absolute value of this one, so this one equal to 1, okay, so we will have EL, absolute value of EL, which is EL, I will have minus EL, okay. I'm going to take the reciprocal of this one, L plus e to the minus L. I will have this term, 1 over this term is inferior or equal to 1 over this term, e to the L minus. So I will have this integral 2 times from 0 to pi e to pi a y. The same thing here, the integral from 0 to pi e to this term to pi a y dy here. I'm going to multiply numerator and denominator by e to the minus L. So we'll have the integral from 0 to pi, 2 times of this integral. We will have e to pi ay is multiplied by e to the minus L over, I will have here 1 minus e to the minus 2 times L. So when L is going to infinity, y is going to 0. As L is going up, this y is going down. When L is going towards infinity, y is going towards 0. Now L is going to infinity, y is equal to 0. If you take a look, this one becomes 0. this become y equal to 0 become 1. This term become equal to 1. This term becomes 0. This means 0 over 1, which is 0. The whole integral is going to be 0. Okay? So now the integral of z dz over c over path c2 we found equal to 0. So the integral over the path c4, we are going to do the same job. So it will be also the integral f of z dz over c4 equal to 0. So we already calculated the integral, so the residue of this function at the point pi over 2i equal to the limit as z is approaching to pi over 2i of z minus pi over 2i is multiplied by minus e to the minus 2i pi a z over cosine hyperbolic function z. Okay, so if you replace z with pi over 2i is giving you indeterminate form. Now I'm going to apply the Hopital rule in order to evaluate this limit. Before I'm doing that, I'm going to switch these terms. This cosine become underneath of this one, cosine hyperbolic function of z. So if I'm applying the Hopital rule here, I'm derivating this one is giving us 1. This one is giving you sine of hyperbolic function z. Okay, so I'm going to replace, so our residue at this point is giving you e to the minus 2i pi a. I'm going to replace z with pi over 2i over sine hyperbolic function of this one at the point pi over 2i. These two will be cancelled out with these two. I is multiplied by I, which is I squared, minus I squared is giving us 1. So this one equal to e to the pi squared a over sine hyperbolic of pi over 2i. If you take a look at here, the sine of hyperbolic function at the point pi over 2i equal to 2i pi over 2 minus to the minus e to the minus I pi over 2 over 2. If I'm dividing by I and multiplying by I, so this term, this is Euler formula. This term is a sine of pi over 2, which equals 1. The sine of a hyperbolic function pi over 2i equal to I. So the residue of pi over 2i is giving us e to pi square a over I. Now I'm going to plug all this information into the expression to see what's the result of this integral. Okay, now I have this integral, I have 1 plus e to pi squared a is multiplied by this integral minus pi minus infinity to plus infinity. We have this integral to minus 2i pi ax over cosine hyperbolic function of x dx plus 0 equal to pi I is multiplied by residue of this function, which is e to pi squared a over I. This I will be cancelled out, so this integral equal to this one, this integral equal this one over this one. So integral as from minus infinity to plus infinity, e to the 2 minus 2i pi ax over cosine hyperbolic function of x dx equal to 2 pi is multiplied by e to pi square a over 1 plus e to pi square a. So what I'm going to do now, I'm going to divide numerator and denominator by e to pi square a. So I will have 2 pi is divided by e to the minus pi square a plus e to pi square a. I'm going to divide numerator and denominator by 2. What this term is, this is cosine hyperbolic function pi over cosine parabolic function of pi square a. Now our integral in terms of x I equal to from minus infinity to plus infinity, okay, of e to minus 2i pi ax over cosine hyperbolic function of cosine hyperbolic function x dx equal to pi over cosine hyperbolic function of pi square a. So this is the value of this integral. Now I have done with this problem. Just consider the subscribe. If you have any question, just put it in the comment section below. Thank you for watching. I will see you in next video. Bye.